Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0113, refers to a high voltage issue within the intake air temperature IAT sensor circuit. This code indicates that the voltage readings from the IAT sensor, which measures the temperature of the air entering the engine, exceed the acceptable threshold. A high IAT may lead to performance issues such as reduced fuel efficiency, poor acceleration, or even engine stalling. This sensor is crucial for the engine's performance and efficiency, as it helps the engine control module, ECM, adjust the fuel-air mixture for optimal combustion. In the Honda CR-V models from 2011 to 2016, the IAT sensor is located in the mass airflow MAF sensor assembly. And when it malfunctions, it could compromise the overall engine function. To address this issue, a systematic approach to troubleshooting the problem is essential. The IAT sensor plays a significant role in automotive engines by providing accurate air temperature readings to the engine control module, ECM. Specifically, it helps determine the injector pulse width and ignition timing, optimizing the combustion process. In the Honda CR-V, the IAT sensor is integrated within the MAF sensor assembly, typically located near the air intake. The precise readings from this sensor are vital for the engine management system to maintain optimal performance levels. A malfunction in the IAT sensor circuit, as indicated by DTC P0113, can lead to elevated voltage levels, causing the ECM to respond incorrectly. This could ultimately result in various performance issues, such as decreased fuel efficiency, sluggish acceleration, and other driving anomalies. Several potential causes can lead to the DTC P0113 being triggered. The most common reason is that the voltage reading from the IAT sensor exceeds the threshold limit of 4.92 volts, which indicates an irregularity in the sensor's operation. Another underlying issue could be a faulty IAT sensor, which may require replacement to restore its functionality and ensure accurate readings. Wiring problems such as disconnected, damaged, or corroded wires connecting the sensor to the engine control module, ECM, can also contribute to this DTC. These wiring issues can lead to intermittent faults, causing the system to operate erratically. It's essential to methodically investigate each possible cause to ensure accurate diagnoses and effective repairs. When DTC P0113 is active, several symptoms may become apparent in the Honda CR-V. One of the most noticeable signs is poor engine performance, which can manifest as hesitation or stalling during acceleration. This symptom is typically linked to inadequate combustion due to incorrect air-fuel mixture adjustments resulting from erroneous sensor readings. Additionally, drivers may experience a decrease in fuel efficiency, meaning the vehicle consumes more fuel than usual for a given distance. This can be frustrating and costly over time. Another potential symptom is an increase in emissions, as the engine may be running too rich or too lean, failing to meet environmental standards. Paying attention to these symptoms can help in identifying the issues early on, potentially preventing further complications. To commence with the troubleshooting for DTC P0113, the first step is to turn the ignition switch to the on position. 2. This action powers up the vehicle's electronic systems and prepares the diagnostic equipment for the assessment. After the ignition is on, use the Honda Diagnostic System, HDS, to check the current values of the IAT sensor. Specifically, look for voltage readings. If they exceed 4.92 volts, investigate further. If the readings match the set threshold, you've validated the failure condition, and you can proceed to the next troubleshooting step. Conversely, if the readings do not match, consider that the system may be operating intermittently, which necessitates checking for poor connections or loose terminals at the MAF sensor/IAT sensor and the powertrain control module, PCM. Properly documenting all findings is crucial for a comprehensive diagnosis. In the second step of troubleshooting DTC P0113, the next action is to disconnect the MAF sensor/IAT sensor 5P connector. This disconnection is essential for isolating the IAT sensor from the circuit for further tests. After disconnecting, use a jumper wire to bridge terminals A and B, specifically connecting MAF sensor IAT sensor 5P connector number 1, red, and number 2, gray. Doing so allows the system to bypass the IAT sensor temporarily, helping to determine if the sensor or the wiring is at fault. Following this, turn the ignition switch to the on position again, and again check the voltage signal using the HDS. You should expect to see IAT sensor readings higher than 4.92 volts. If the voltage matches, the issue lies within the IAT sensor itself, prompting a replacement. If the readings remain erratic, further investigation into wiring issues is warranted. In Step 3 of the troubleshooting process for DTC P0113, the focus shifts to measuring voltage to determine the integrity of the signal lines. Begin by turning the ignition switch to the lock position 0 to safely disconnect any current flow. Next, remove the jumper wire you installed in the previous step. After disconnecting the jump wire, turn the ignition switch to the on position I once again. Using a multimeter, measure the voltage between test points 1, MAF sensor, IAT sensor, connector number 1, red, and test point 2, body ground. Under normal conditions, the voltage should read approximately 5.0 volts. If this voltage is present, you can proceed to the next troubleshooting step, as it indicates that the power supply path to the IAT sensor is intact. If the reading is significantly different, focus on investigating the wiring conditions further, as potential faults may exist within the PA line or SG2 line. Step 4 continues the diagnostic evaluation for DTC P0113 by assessing the continuity of the SG2 line. Start by making sure the ignition switch is in the lock position, 0. Ensuring a safe working environment. Next, use the HDS to jump the SCS line. This is a short circuit check used to isolate possible issues that could affect the system's function. After that, disconnect the PCM connector B, 49P, to facilitate an accurate continuity test. Using a multimeter, probe test points 1, PCM connector B, number 44, gray, and 2, MAF sensor IAT sensor connector number 2, gray, to check for continuity. If continuity exists, it confirms that the SG2 wire is functioning correctly. If continuity is absent, it indicates an open circuit that necessitates a repair in the SG2 wire, so you can continue diagnostic measures toward restoring proper function. Step 5 of the troubleshooting process for DTC P0113 involves checking the continuity of the TA line, which is crucial for the operation of the IAT sensor. Start this step by ensuring the ignition switch is in the lock position, 0. Like the previous steps, jump the SCS line using the HDS for accurate testing. Next, disconnect the PCM connector B, 49P, to facilitate a continuity test without interference. Measure continuity between test points 1, PCM connector B, number 42, red, and 2, MAF sensor, IAT sensor connector number 1, red. If the multimeter indicates continuity, the TA wire is functioning as intended, and if any more issues arise, it may be advisable to update the PCM software. However, if continuity is absent, it indicates damage or an open in the TA wire, which necessitates immediate repair before resuming further diagnostics. After completing the repairs associated with DTC P0113, it is vital to conduct a final verification process to ensure the issue has been fully resolved. Begin by turning the ignition switch to the lock position, 0, and carefully reconnect all disconnected connectors. This is key to ensuring that all components of the system are properly linked and set for testing. Next, use the HDS to reset the PCM, too often necessary after making significant changes to the vehicle's electrical system. Once the PCM has been reset, be sure to complete the idle learn procedure. This step is critical for allowing the engine control module to accurately adapt to the changes in the engine system, optimizing fuel delivery and ignition timing. After performing these steps, check for any pending or confirmed DTCs using the HDS to verify the success of your repairs. Preventive maintenance can go a long way in avoiding issues like DTC P0113 in the future. Regular inspections of the IAT sensor and MAF sensor ensure early detection of potential faults. During these inspections, also check all wiring connections for wear, corrosion, or loose connections, as they can contribute to erratic sensor readings. Additionally, keeping the PCM's software updated should not be overlooked. Manufacturers often release updates to rectify minor bugs and improve performance. Taking these precautions can prevent situations that lead to costly repairs and prolonged vehicle downtime. Committing to a preventative maintenance schedule is beneficial for long-term vehicle health and reliability. In conclusion, DTC P0113 indicates a high voltage issue within the IAT sensor circuit, highlighting a significant malfunction that needs addressing for optimal vehicle performance. The IAT sensor plays a critical role in determining how effectively an engine runs by communicating essential temperature data to the ECM. By following a systematic approach to troubleshooting, mechanics can identify faulty components, such as the sensor itself or wiring connections, thus enabling accurate and efficient repair methods. Regular preventive maintenance is vital, not just for avoiding issues, but also for ensuring that the vehicle remains responsive and efficient. Overall, understanding the implications of DTC P0113 and the required steps for resolution helps restore the performance and reliability of the Honda CR-V. Please like and subscribe to the channel. See you next time!